Seventh grade, we are in week 11 and we are on our last section of this week. We're still talking about Earth's layers. Yesterday we talked about the surface layers, the layers that we have contact with. Today we're going to be talking about the innermost layers. So what's below our feet? And we're talking way below our feet. If we could cut the Earth open, we could see these different layers. As a learning target, we should be able to demonstrate how the inner layers of the Earth differ in composition and how they differ mechanically. Okay. So when we're talking about composition, it's what it's composed of, it's what it's made of. That's its chemistry, isn't it? We've talked about chemistry before. When we talk about it mechanically, that's how it acts, how it interacts with different things. Those are its physical characteristics. So we're going to be looking for chemical and physical characteristics of the inner layers of the Earth. Are you ready? Awesome, let's do this. So let's say we cut the Earth open, just for fun. Don't really do that because it would be really bad. But if we could cut the Earth open, we'd see the following layers from inside to outside. From the inside, we'd see the inner core, here represented in yellow, the outer core, represented in red, the mantle, which is light brown, and the crust, which is dark brown in this picture. Now, you can also think of the brittle lithosphere riding on the plastique asthenosphere. Okay, so we're going to have to talk about those a little bit later after we talk about our composition. We'll talk about how they physically interact, okay? Because there's two ways of looking at the inside of the Earth. We're going to talk about the side on the left first, okay? That's the one that probably most of you are familiar with, all right? So on the left-hand side, we see the layers of composition. The layers scientists recognize are pictured here. The core, the mantle, and the crust are divisions based on their composition, what they're made of, their chemistry. The crust is less than 1% of the Earth by mass. The two types are oceanic crust and continental crust. Now, oceanic crust, the crust that's underneath the ocean, is way, way, way more dense than continental crust, okay? So it's more dense, it's also more heavy, okay? And so if we were to put them next to each other and try to float one on the other, the continental crust would actually float on top of the oceanic crust. If you had a basketball, all right, I want you to picture a basketball, and you took spray paint and just quickly, not very thick, just spray painted your basketball, one layer of spray paint. The paint would be like the crust, and the basketball would be like the rest of the Earth. That's how thin the crust is. 1% of the total Earth's mass. The mantle is hot, dense, dark in color, dark, ultramorphic, in other words, if you remember that word, rock. It represents 68% of the Earth's mass. That's a pretty good amount. So the mantle is pretty thick. The core is mostly metal, and the core makes up 31% of the Earth. The Earth's metallic core has two layers, a solid inner layer and a liquid outer layer. Now, I often get asked the question, why is the inside of the Earth solid? Why is the inside of the core solid? And the outer core is liquid and the mantle is liquid. I mean, it's so hot, right? Wouldn't the innermost core be liquid too? Well, the thing is, it has to do with pressure. And there is so much pressure that it's not able to change from a solid to a liquid. It actually is forced to remain a solid. And it's not able to change into a liquid, even though it is very, very, very hot. Okay? The terms core, mantle, and crust will be described in more detail as we talk about these various concepts. Now, let's look at the mechanical layers or the physical structure of the Earth. We talked about the lithosphere, and remember the lithosphere is part of the upper layers, so we consider that part of the upper layers also, and the asthenosphere, and they're divided based on mechanical properties. The lithosphere is composed of both the crust and the uppermost part of the mantle. It is solid, brittle, rigid, easy to crack, okay, or be broken up. It's what we would call pretty much rock. The upper mantle, still super hot, but it's cooled down around, enough that it's mostly rock, okay? The asthenosphere is below the lithosphere. The asthenosphere is also in the upper mantle. And this layer is solid, but not quite so solid. In fact, it's what we call plastique. And it can flow and bend. And it flows kind of like clay. If you were to mold clay in your hand, you can move it around, right? And the lithosphere actually floats on top of the asthenosphere. And these two spheres, both part of the lithosphere and all of the asthenosphere, is part of the upper mantle. Now, there's also a lower mantle, which is more rigid than a asthenosphere, probably due to pressure, but it is liquid. The outer core, which is a liquid phase also. And then we also refer to the inner core as the inner core. So not much change between mantle, inner core, and outer core. But crust and upper mantle do get divided into asthenosphere and lithosphere because of the way that they interact physically, their physical characteristics. So let's go ahead and summarize. By comparison, Earth is divided into core, mantle, and crust. By composition, sorry. By mechanical properties, the crust and upper mantle are divided into lithosphere and asthenosphere. It all has to do with how they move over each other. The core, mantle, crust divisions are based on composition. The lithosphere, asthenosphere divisions are based on mechanical properties. Excellent. So if you're okay with being able to explain how the inner layers of the Earth differ in composition and mechanically, then by all means, move on. If not, feel free to go back and review the video. Again, this is our last learning target for this week, and you can move on to the next activities, and hope you have a great week coming up. Talk to you later. Bye now.